can see the classroom.
Okay. Maybe it took a few minutes to adjust.
Yes.
Because I didn't actually do anything.
Yeah.
Okay. Okay, so what we're going to do today is take this binary deanery a little bit further.
Yes.
I assume you've heard of Hex because you mentioned having done some HTML?
Yes.
Okay, so can you remember how you might have used hexadecimal in HTML?
Hexadecimal. What's hexadecimal? Is it?
Don't worry if you can't. I was just going to see if you remembered. So don't worry about that. When you use, can you remember when you did HTML?
Yeah, it was like 5 months ago.
Okay, good. Can you remember trying to make colours?
Yes, yes.
On your webpage?
Yes.
Now, to make a colour, did you use a word like red or yellow, or did you use a number with a hashtag in front of it?
I used the word and number. And not a number, just a word.
A word, okay, that's good. So when you're doing HTML web pages and you use a word for a colour, how many colours do you think you could actually use if you could only use a word for the colour?
How many letters?
The answer is not many, is it?
Yeah.
I mean, you're restricted because, I mean, you've got red, blue, green, yellow, blah, blah, blah. But actually, with a word, you don't have a choice of many colours, do you?
Yeah.
So what people do when they get more experienced with HTML web pages, they actually use a number, a hexadecimal number, instead of using a word. And that means they can have thousands and thousands and thousands of different choices of colour. So, for instance, if you just look at your screen, you know, on the Tutorful thing, you know, the little mortarboard hat thing that is next to the word Tutorful?
Yes.
Yeah? Now, you could just describe that as blue, couldn't you?
Yeah.
But very specifically, do you think you could actually get that exact precise colour if you tried? It would be very difficult. So the whole purpose of using these hexadecimal numbers for colours is that you can get an absolutely precise colour that you want. And these days, with so many web pages and whatever, you want a huge range of colour, don't you?
Yes.
So basically, that's one of the reasons that hex is used. So we're going to look at what hex is, just so you know. But before we get there, let's just step back a bit into binary. So why is data represented as binary on a computer?
Because the computer cannot read letters, and it has a certain letter or number has to be, or like a space button has to be represented by numbers.
Yep. And what can the computer represent it as? Which only has two choices, doesn't it?
Yeah.
What can it represent it as?
On or off.
Exactly right. So a 0 or a 1. So in your book, for a start, first thing you're going to write is the answer to this one.
Yes.
So data is represented as binary in a computer because, and what's your answer going to be? Because
data.
Yeah. So data is represented as binary in a computer because. So now we need to think, why is it 0 and why is it 1? What does 0 represent?
On.
Off.
Off, yeah.
And what does 1 represent?
On.
Good, exactly right. So the whole reason binary is used in the computer is because the computer only understands on and off switches.
Yes.
So that's what you need to write as your answer. So data is represented as binary in a computer because it can only understand switches that are on or off.
Done.
Okay, and do you remember the name of the person that came up with the term
Yes.
binary digits? What's his name?
Claude Shannon.
Excellent, well done, Claude Shannon. So he's on the screen now. So he came up with the word binary digits, which we shortened down to bits. Yep.
I don't see anything on the board. It's just white.
Oh, really?
Yeah. Should I refresh?
No, hang on. Can you see it now?
No, it's just black. Because it says you're sharing your screen.
Yeah.
Yeah.
But you're not seeing that, no?
It happened last time. Should I refresh?
Can you see it now?
No, it's just black.
Okay, I think you need to refresh then.
Okay. Start. Allow. Yes. Hello, hello, hello. Yes. Testing. Yes. Yes. Okay, I can see now.
Ah, perfect. Well done. Good job.
Yes.
It's the answer to many a question. Turn it on and off again.
Yeah.
Okay. So we're going to today we're going to convert binary and decimal into hexadecimal.
Yes.
If you remember, we call binary base 2 because it only has two options, on and off, 1 and 0. And we call denary base 10 decimal because we have 10 digits. One of those, remember, is 0 because the computer starts counting at 0. And what we call hexadecimal is the amount of characters that we can use, and that is 16 because it runs from 0 to 15. So we call hexadecimal base 16.
Yes.
So want to just remind you about the different binary digits that we have available. So we have the bit, which is just one digit, a 0 or a 1. Do you remember how many bits there are in a nibble?
4 bits or half a byte.
Good. And we are going to work with nibbles today. So that's really important that you understand the nibble. And then the byte is how many bits?
8 bits.
Excellent. And then it just keeps going up. So that's all I'm going to do there. So this is just looking back at what we did before. So if you remember, when we convert decimal to binary or binary to decimal, we need to draw that grid of 1, 2, 4, 8, 16, 32, 64, 128 so that we can see which switches are on and which switches are off.
Yes.
So in this case, 64 is on and 1 is on, so it's 64 plus 1, which makes 65. Good. Now, when we use hexadecimal, we can use just 4 bits. So we are going to use the nibble. So in this case, we are only interested in the 8, 4, 2 and 1. So in this case, we've got 8, 4 and 1 switched on, which is 13. And in actual fact, this represents the return key on the computer.
Yes.
Okay, so, right. Can you remember doing decimal to binary, or do you want me to go over it again?
Yes, I know. Decimal.
You did, and this was the opposite, decimal to binary. Okay, so now this is what we have got today. So the hex is short for the word hexadecimal.
Yes.
And it uses a combination of numbers and letters in order to represent a number. Now, the reason for this is because we're human and we can't cope with remembering all those zeros and ones. So if we have a full byte of zeros and ones, 0101, 11101, etc., we can't actually remember it because we're human. So what programmers started to do was to use hexadecimal, which actually uses the numbers 0 up to 9, and then it stops, and it uses A, B, C, D, E, F. There are no letters after F. It stops at F.
Yes.
So instead of having, for instance, 15, and we're saying it's 1111111, in hexadecimal we can just say it's F, which is easier for us as humans to remember. So the reason hexadecimal is used is because it's quite useful in programming, just for programmers to talk about numbers and digits, because we can remember these better than we can remember long binary numbers. And that means there's less chance of us making a mistake.
Yes.
Now, I want you to be drawing this grid,
Yes.
but don't do it yet. Now, what we're going to do, we're going to have 3 columns, and we are going to put the decimal numbers on the left-hand side. We're going to convert them to binary in the centre, and then on the right, we're going to put the hexadecimal number. Now, the reason for this is, if you ever do a GCSE exam in computer science, there are always questions on converting binary, denary, and hex. And actually, at GCSE level, they won't be as easy as just doing binary to denary. They will always include converting it to hexadecimal. Now, the thing you need to remember is you can't immediately turn decimal into hexadecimal.
Yeah.
You can't immediately turn hexadecimal into decimal either. So you always have to change the decimal to binary and then to hex.
Yes.
Now that makes it quite complicated if you're sitting in an exam. So the thing to do is, if you ever get a question about converting decimal, binary and hex, if you actually draw this table in front of you, it helps you remember what you need to do.
So that,
Yeah, hang on, don't do it yet. So remember, hex starts at 0, stops at 9, and then it goes from A to F. So this is 16 characters, which is actually, 2 bits, two bytes.
Yes.
But it never, ever, ever goes above F. It can only go as far as that. So this is what we're going to do. So on your sheet, the easiest way to do this, because you need 16 rows, if you draw a long rectangle, and then you split it in half again, split it in half again, and split it in half again, you roughly end up with about 16 rows. So you need a grid that is 16 rows and 3 columns. And it needs to be just big enough to write the numbers in.